OpenClaw is an open source AI agent that runs on your local machine, and it is able to connect to all your favorite tools. Running it locally has two problems. The first one is pretty obvious. It just runs if your machine is actually up. The second one is worse. OpenClaw has access to all your files on your computer, to your browser, and to everything else. That makes it powerful, but also very dangerous. If OpenClaw gets compromised and it's running on your local machine, they get access to everything. Your SSH keys, your local files, your browser cookies, everything. So what is the fix for that? It's pretty simple. Don't buy a Mac Mini, just run it on AWS. The solution is easy and it's very cheap. We can run OpenClaw on a dedicated Lightsail instance on AWS. And it's also pretty easy to set up. Let's do it right now. So this is the architecture we want to set up. It looks complicated, but it actually isn't. The first thing we can see is Lightsail. So OpenClaw will run inside a Lightsail instance. We will access the Lightsail instance via the session manager. This means we don't need to open any SSH ports. We will also enable Cloud Code to access our instance, because it's also able to connect to it via the session manager. This allows us to decouple the process of developing skills from running the agent itself. This brings us the advantage that we can use the latest frontier models for developing our skills and not mixing it up with the agent itself, because running the agent can get expensive very quickly. I suggest just using a cheap model for your agent itself, because it is very good at burning a lot of tokens quickly. All of the agent's memory is just stored in MD files. This is pretty simple and brings us the benefit that we can simply set up a GitHub repository to have a local change history for everything. If the agent messes up hugely, we can just roll back to a safe state from the past. We will connect the repository simply to GitHub via deploy key. We will talk to our agent via a Slack app. If you prefer, you can surely also use Discord or Telegram. We will also connect our agents to AWS, to the Gmail API, and to the Notion API. So what are the things we need to do? We need to deploy our Lightsail instance. I prefer using Terraform, but you can also go with the console. Then, next, we need to prepare it. We need to activate SSM because it's not activated by default. We need to provide it with some AWS credentials because we want the agent to be able to connect to the AWS API. And then we also need to install Go and Node.js. Next, we can already install and configure OpenClaw. The most important thing is connecting it to an LLM provider. In our case, we will just use OpenRouter because we can use every model underneath it. Next, we will connect it to Slack as our main messaging channel. Afterwards, we will also connect it to Notion and Gmail, and we will tell him that he's also able to connect to the AWS API. And that's basically it. Let's jump into it. So now let's have a look at the code. As you've already imagined, it's pretty simple. I've created a custom module because everything is in my main repository, so the code for OpenClaw stays in one place. Let's have a look how the module looks like. As you can see, the module is pretty simple. We are basically just using 3 different AWS services. Obviously Lightsail, then the systems manager to getting access to the instance without SSH, and obviously IAM to setting up permissions properly. Let's have a look how that looks like. So in the Lightsail file, we can see that we are setting up the Lightsail instance. We are also referencing a user data script. This is the script that is executed at the bootstrap time. As I told in the beginning, we used that to install all the necessary dependencies like Node.js, for example, the AWS CLI, and also Go. We will have a look at that shortly. Let's look at the other things that are going on here. Lightsail is highly abstracted. This also means that it's not by default available via the sessions manager. We need to do a few things to make this happen. The first thing is we need to create a role that can be assumed by the SSM principal. This role will also get a managed policy by AWS. We don't need to create this on our own. The next thing is that we create a so-called SSM activation. This activation is bound to the role we've created previously. It's basically a one-time token that consists out of an ID and a token, and it will be later used to activate our instance for being used with SSM. Before our instance is created, we are pulling our bootstrap script and passing in some variables. For example, for our activation, we will pass the ID and activation code. Then the Bootstrap script can take care of registering our instance while it's bootstrapping with SSM. This means when the bootstrap is finished, we are immediately able to connect to the instance via our own credentials and not via SSH and not via some certificates or keys, which is much more secure. So what are we doing in our Bootstrap script? It's pretty simple. We are activating SSM and then we're installing all of our dependencies. So Node.js, the AWS CLI, also Go, because we're using another dependencies that's based on Go to access Gmail securely via OAuth. Then we are also making sure that SSM is really activated and working. Then we are setting up our AWS credentials. As mentioned previously, as Lightsail doesn't easily support a custom role, we'll just pass in the credentials of a custom user. Next, we are already installing OpenClaw and afterwards our third-party tool to accessing Gmail. And that's basically it. We always need to make sure that the binaries are correctly exported to our path. The easiest way to do this is to write the path extensions to our SSM users /rc. As you already saw, I already run my Terraform and the instance is already created. Don't be confused that I have 4 gigs of RAM and 2 vCPUs because I've picked a larger instance, so our whole setup is a little bit faster, but you can surely use the smaller ones. What I want to add here is you can obviously also create all the steps not via code by just using the web console. Just go on create instance, select your favorite region, then select Linux, Unix, click on operating system only, use Ubuntu probably, then scroll below to adding the launch script. You can use mine, but be sure if you want to use the web console SSH connection, which is pretty nice, it will always use the Ubuntu user and not the SSM user. So you need to switch the paths from my script from SSM user to Ubuntu, but that's the only thing you need to adapt. Then you can select an SSH key, either one that already exists or you upload one from your local machine. And afterwards you can already select the instance type you want to use general purpose, and then pick one of the smaller instance types. As I said before, $5 one is perfectly fine, but it will be rather slow, especially for the OpenClaw configuration and setup. Maybe use the $7 one if you can afford it per month. All of the free lower tiers come with a 90-day free tier usage, so you won't pay anything, and then you can decide which is the one you will use on the long run. Then we can scroll to the bottom and just click create instance, and after a few minutes we are ready to go. So I've already connected to my instance via the AWS SSM create session command, but as I've said in the beginning, if you want to use SSH or you created it via the console, you can either use the console directly or just connect via your SSH key and the IP that is displayed in the console. Now we can directly jump into the configuration wizard. Let's run OpenClaw Onboard. Let's accept the security warning with yes, then go into the quick start mode. Let's use existing values. And next we need to configure our LLM provider. In our case, we want to use OpenRouter, because with this we can use basically any LLM provider beneath. Now we need to paste in our API key. You can get your API key via the console UI easily. Now we can select the model. Here we should be very careful because OpenClaw is very good at burning a lot of tokens if he gets into a complicated loop or if it runs a lot of background jobs. My recommendation is using a smaller model like Gemini 2.5 Lite, works perfectly fine, or GPT-5 Nano is also very good. I think both are either 10 cents per 1 million input tokens or 5 cents per 1 million input token, so you can do a lot with them without burning too much costs. So let's go through the list and find one from OpenAI. There it is. We will use GPT-5 Nano, which does a lot. Next, we need to select our communication channel, In our case, we want to use Slack, but you can also use any other like Telegram or Discord. Now we can select the display name. You can pick anything you like. I will name it 𝗟𝗶𝗺𝗀𝘀 because 𝗟𝗶 is the name of a Pokemon and I like it. And now we will be already presented with the configuration that we need to do in Slack. So we need to go into the Slack API and create a new app that will be registered to our Slack. And the tokens need to be put into the OpenClaw configuration so that we can continue. Now we are at the Slack API administration where we can create a corresponding app for our bot. Let's click on Create App, select from a manifest, because then we can just copy the JSON that OpenClaw was printing for us, because it's already properly configured for our use case. We need to select our workspace, then click Next. Then we can just replace it with our own JSON, just paste it in and click on Next. And then we already see that the bot has all the scopes that we need and we don't need to fiddle around manually. We can also see that the correct name is already configured, and we can see that under settings, the very important socket mode is already enabled. Let's click on Create. The only thing we need to do is to create the corresponding tokens that we need. Let's scroll down to app level tokens and click on Generate Tokens and Scopes. Then we name it just OpenClaw. We will add the scope connection right because the bot needs to be able to open and close connections. And then we click Generate, and then we have the first secret. It always starts with xapp-. Let's copy it. Then let's scroll up again, go into the tab OAuth and Permissions. In this tab, we can install the app into our Slack. Let's click on the install button. We will be prompted with the permissions, so we can accept that. Click on Allow. And now we get the next token, which always starts with the XOXB- prefix. Let's also copy it. Now we are already ready to go to jump back into our configuration console. So now we are back into the console. Let's paste our tokens in there. We don't need to configure the channel, so just select no. Also, we don't want to configure any skills for now, so no. Then we will skip the hooks also, and that's already it. Our bot is ready to go. As you can see, our new app, which is called 𝗟𝗶𝗺𝗀𝘀, is already registered at our Slack. I already opened the chat up and sent him a message with what's up. For the first message, we need to run another approval command. So let's copy the command from below with the pairing code and just run it in our Lightsail instance. After we've done that, our bot is ready to go. So let's verify that immediately. As we can see, no response was retrieved. So something must be missing. Let's check in our debug logs for OpenClaw. As we can see, socket mode was connected, but it says Slack final reply failed. The final reply failed because of a missing scope. We can fix this easily. So we are back into the Slack API administration in our configuration of our 𝗟𝗶𝗺𝗀𝘀 app, and under OAuth we can see that we've somehow missed the most important scope, which is IM::read and write. So let's just add it here to make everything work. After adding the scopes, make sure that you need to reinstall the app so that the permissions are really updated. So we reinstalled the app, went back into Slack, then we sent another message, and we can see finally our 𝗟𝗶𝗺𝗀𝘀 is ready to go and he's ready to receive and answer messages. What we can also check is making sure that we are using our picked open router model and that it didn't fall back to using the auto mode, which can be quite dangerous. So let's just ask our bot if he's able to determine which model he's using. And we can see he's properly set up. He's using Open Router and the GPT-5 Nano model. So after our bot is ready, you can truly develop just your own skills, but you can also use the ClawHub because there are already pre-made skills by the community that you can just browse and use. What I really found very useful is, for example, the Gmail skill. So we can just put it into the search. The Gmail skill is based on a CLI that was also created by the developer of OpenClaw, and we've already installed it on our instance via the Bootstrap script, so you can just use the skill easily. The same goes for other skills. So for example, Notion is really useful. It can help you to browse your knowledge database if you're a heavy Notion user. I really like that. Installation, as before, download the skill files, copy it into the skills folder, and you're ready to go. For both skills, so Notion and Gmail, you also need to provide credentials from the provider side, which means on Notion you need to create an integration for which you will also retrieve a secret. For Gmail, you need to create an OAuth credential. You can do that on the Google Cloud Console. You also need to provide it with the correct scopes. So for example, you can assign scopes of reading your inbox, or also sending emails, or reading your calendar, or also writing to your calendar. It's basically up to you how powerful your agent wants to become. In this video, we didn't cover all the parts in very much detail like it would be necessary. So for example, the infrastructure as code part was really fast, and in the end, we didn't have time to show you how to set up the Notion and the Gmail access. We also didn't cover a small use case for the AWS API. That's why we wrote a detailed blog article that you can check out for free. The article goes really in depth and it covers all the necessary steps so you can follow at your own speed. Also, if you're interested, consider subscribing to our free bi-weekly newsletter where we are covering a lot of cool things like that on a regular basis. Thanks for watching and see you next week.